Hi guys, today's topic is solving equations when you have variables on both sides of the equal sign. And the date today is October 23rd. You should be on page 32. Make sure to put those into your notebook. And our objective is simply, I can simplify and then solve equations with variables on both sides. Okay? So let's just jump right into it. On this same page, on page 32, I want you to copy these steps down for this process. First, we are going to combine like terms. Oop, I forgot a parentheses there, sorry. We are going to combine like terms. And the number one thing to remember when you're in equations like this is that when you're doing this first step, do not cross the equal sign. And I will show you an example of that in just a minute. But just write it down, highlight it, draw attention to it. You can't cross the equal sign in this first step. And that'll make more sense in a few minutes. The second thing to do is that you're going to bring all of your terms that have a variable to one side of the equal sign, and you're going to do this by using inverse operations. So the fact that addition and subtraction are opposites, and multiplication and division are opposites. Third step is I'm going to bring all of my terms without a variable, so those are my constant terms, to the other side of the equal sign. So maybe in step 2, I brought all of my variable terms to the left side of the equal sign. In step 3, I'll bring all my constants to the right side of the equal sign using inverse operations, and I'll show you how to do that. And then finally, you're going to solve the equation. Pause the video if you need more time to write. If not, let's move on to page 33 and write this example here at the top of page 33. I'm going to go ahead and cover up that second example because we're not worried about it quite yet. Step number 1 is combining the like terms. Do not cross the equal sign. So I'm going to put like this little wall up here over my equal sign. And that wall is going to tell me, hey, you can't do anything across that wall in this first step. So if I look at just this left side of the equation, I'm going to pretend that I can't see what's on the right side of the equal sign, okay? And I'm just going to combine these terms. So I have 6m, I'm changing subtraction to adding the opposite, and then I have 3m. 6m plus 3m is 9m. And then I have plus negative 10. Once I've combined like terms on the left-hand side, I'm going to check my right-hand side, and there are actually no terms to combine on this right-hand side. The reason I say you can't cross the equal sign is I can't take this 6m, 3m, and combine it with 4m over here. That equal sign has to be a wall. And you can only cross the wall when you use, hang on, I went too far, when you use these inverse operations. So let's go to step number 2 and see what that looks like. So step number 2 says to bring all of your terms with a variable to one side of the equal sign. So I have on the left-hand side 9m plus negative 10, and then I have 4m plus 5. And I'm going to need to bring all of my variable terms, so I have 4m and 9m. I'm going to have to bring them to the same side of the equal sign. And I can do that, watch how cool this is, by saying, okay, well, if I have 4m over here, I don't want that on that side anymore. So I'm going to cancel that out by subtracting 4m. But whatever I do to one side, in order to keep the balance, I have to do it to the other side. See, you can move an entire term over. The 4m and the minus 4m cancel, and then I have 9m minus 4m, which gives me 5m. I still have this plus negative 10 over on the left-hand side, equals, what am I left with on the right? Just this 5 right there. Okay? I think I'm going to have to make this smaller or I'm going to run out of room. So give me just 1 second. There we go. All right. Step 3 in our process says to bring all terms without a variable to the other side. So I brought my variable terms to the left, so now I only have variables on the left-hand side. And now I have to bring this negative 10, I have to bring it across the equal sign, which means I have to use inverse operations. So how am I going to cancel out this plus negative 10? Well, if I think about what cancels negative 10, it's got to be positive 10. So those will cancel. And I'm going to add 10 over here. And that's going to leave me with 5. Oopsie, that's a really odd 5. Hang on. 5m on the left-hand side. And then 5 plus 10, that gives me 15 on the right-hand side. So I have now made an equation that's something you guys know how to solve. 5m equals 15. Now it's as simple as using my balance, and I can finally solve for m. And I'm going to solve for m by dividing both sides. Use a fraction bar for division, remember. Divide both sides by 5 to cancel that 5 out, and I'm left with m equals 3. Okay? And you can always check this. That's the great part about algebra. You can plug this m into this original equation. In fact, I think I'm going to show you that because I think that's important. You can take that m and plug it into your original equation. So I can do 6 times m, which is 3, minus 10, plus 3 times m, which is 3 again, equals 4 times, whoopsie, that looks like a period, 4 times, 1 second, m, which is 3, plus 5. And then if I go to simplify this, 6 times 3 is 18. 18 minus 10 is 8, plus 3 times 3, which is 9. So 8 plus 9, that should be 17 on the left-hand side. Then I have my equal sign, and I say, okay, 4 times 3 is what? Well, that's 12, plus 5 is 17. And you can see that you end up with something that makes sense. 17 equals 17. Sorry. All right, so let's go ahead and try this with another problem. Make sure you have everything written down for this first problem. If not, rewind it, come back to it. And I'm going to make sure that I have enough room on here to do this one. I'm scooching this up. This problem is a little bit different. In this problem, I have parentheses, which means I'm going to have to use distributive property. And I should do distributive property before I combine like terms. We learned how to do that in the lesson from yesterday. So if I use distributive property, first I have to change all of my subtraction to adding the opposite all across my problem. Very important, so you don't make silly mistakes with negatives. And then I'm going to get rid of my parentheses by using distributive property. So I'm going to do 2 times 2 is 4, so that's 4b, plus 2 times negative 3 is negative 6, plus 4b equals 8b, plus negative 12, no parentheses to get rid of over on this side, plus negative 6b. I'm then going to combine like terms. 4b plus 4b is 8b. Remember, when I combine like terms, I can't cross the equal sign. And I have plus negative 6 equals 8b plus negative 6b. 8 plus negative 6 is going to give me 2b. That should be a b, guys, sorry. Plus negative 12. All right, so I've simplified both sides of the equal sign. I'm going to use inverse operations to bring all of my terms with a variable to one side. So I need to bring this 2b over to the other side. In order to do that, I have to cancel it by doing minus 2b. Those cancel. Over here, I'll have minus 2b. So that will be 6b minus 6 equals, that's a negative 12. And my next step is to bring all of my terms with plain old numbers. For example, this -6. Oops, I should have a plus sign there. Sorry, guys. Over to the other side. So if I'm going to cancel -6, I'm going to have to add 6 to both sides. Cross those out. And I end up with 6b equals -12 plus 6. Don't forget your rules of negatives. That should be -6. So we have solved most of this problem, but we still have to do the final step of solving the equation to find out what our variable equals. So I have 6b equals -6. I'm going to draw my balance one final time. Divide both sides by 6 because 6 and b were multiplying. Those cancel, and I am left with b equals -1. Whew. Go ahead and write all of that work down, and once you're finished, you can try this reflection question. I want you to combine like terms, simplify it, solve this equation, and tell me what C equals in Edmodo. Okay, be prepared to show me your work in class tomorrow so we can really see where you went wrong. Thanks, guys. Have a great one.